Hello folks, we are once again back with the exercise 7.4 and question number 18 over here. We've got this integral as 5x minus 2 over 1 plus 2x plus 3x squared dx. See, whenever we have a quadratic in the denominator and a linear in the numerator, our first task is to check what the derivative is. And by any chance, if the numerator is the derivative of the denominator, it eases your work, but otherwise then you'll have to do a bit of work. Like for example, let's look at let's call u. I don't know whether it will be useful, but let's check. Let u be 3x squared plus 2x plus 1. Then in that case, when you look at the derivative is working as 6x plus 2, or maybe if you want you can call it as 2 times 3x plus 1, something like that. But then not a single trace of that is there in the numerator. Okay, so numerator has got no trace of this in the denominator, and it is looking sufficiently complicated. So because in the earlier case we had only the x term, now here there is an x and a constant term in the derivative, and numerator has got no trace of it. So in such cases, what we will do is we will make a small substitution. Let 5x minus 2 be a times this derivative, that is 6x plus 2 plus b. We have to get the derivative in the numerator. There is no way out. Otherwise, we cannot work with the linear in the numerator and quadratic in the denominator. We cannot. So we have to get it. And for that, we are trying to get it into somehow into that form by equating it this way. Now let's see how this will help us. When we try to open this up, it will be 6ax plus 2a plus b. So this is easily correspondable. Okay, like for example, here it is the x term, you can correspond with this, and the constant term you can correspond with this. That means your 6a becomes 5 and your 2a plus b becomes negative 2. So let's see how this will work. A therefore becomes 5 over 6, which you can carry it there. So a is 5 over 6. So what's b? Let's find out. So the b is going to be, that's 3 here. So b is going to be negative 2 minus 5 over 3. So that is when we equalize, it is times 3 times 3. So 6, negative 6 minus 5, negative 11 over 3. So you've got both a and b. Now we are going to see how this is going to work. Yeah, let's consider this. Let's not go for the integral. Let's consider 5x minus 2 over 3x squared plus 2x plus 1. This is now going to be written as a times. It's going to be written as a times. So you've got the value of a. A is 5 over 6. Yeah, it can be written as 5 over 6 times 6x plus 2, and b times plus b. So that's going to be, b is going to be 11 over 3, negative 11 over 3 over 3x squared plus 2x plus 1. So you've got it converted like this. What is the advantage? That your I is now becoming, you can have the 5 over 6 outside. You can separate these terms. 5 over 6 outside, 6x plus 2 over 3x squared plus 2x plus 1 dx. And this term is going to be 11 over 3 outside, dx over 3x squared plus 2x plus 1. We will suspend that for some time, and this is easy. This is easy by, because you have all this, you just have to implant it there, and this part will be, it's going to be better. But this is not going to be so good. Why? Because they are completing square we have to apply. So let's consider that complete squares and then come back. So also let's look at 3x squared plus 2x plus 1, which when we technically see it, it is root 3x the whole squared plus 2x plus 1. Now, we always have the 2ab. So 2ab is 2 here, out of which a is root 3. We are seeing it. 2 root 3, b is 2, which means b is 2 over 2 root 3, which is 1 over root 3. That makes it very clear that you are going to, in order to get this equated, in order to get this completed squares, you have root 3x the whole squared plus 2x. You will add and subtract b squared, which means you will add and subtract 1 over 3, because b is 1 over root 3. So add and subtract. So here it's going to be root 3x plus 1 over 3 the whole, 1 over root 3 the whole square. And this, if you equalize, times 3 times 3, so it is 3 minus 1, 2 over 3. So that's, if you write it in root form, 2 over 3, root 2 over 3 the whole squared. So all this is what we have got over here. Yes, so now let's come back to I is now becoming 5 over 6. We are going back to u because 6x plus 2 dx is du for you. So du, and this is u. I hope there is no root, because all the time, sometimes I overlook the root and then we get into a mess. Yeah, so that's about it. And then you have next part, which is minus 11 over 3. I hope it's a minus. Yeah, it is a minus. Yeah, minus 11 over 3, and then you have this. So here it is dx over, we have completed squares, which is making it root 3x plus 1 over root 3 whole squared plus root 2 over 3 the whole square. Now this is of the type integral dx over x squared plus a squared. So that is tan inverse 1 over a tan inverse of x over a plus c. So let's get back to all this. 5 over 6, this is easily log modulus u, so that part is done. Minus 11 over 3, 1 over a for us is root 2 over root 3. So 1 over a, 1 over root 2 over root 3, 1 over a, tan inverse x. X is root 3x plus 1 over root 3, and over a is again root 2 over root 3. Oh, lot of work is there. So this is fine. Plus c. Should never forget plus c. 5 over 6 log modulus. What is that? 3x squared plus 2x plus 1. And yeah, let's make all the simplifications here. 11 over 3 root 2 over root 3, and then when the tan inverse is not in simplified form, no, this root 3 can come there and it can become 3x. So it can become, say, yeah, when I write this, I should have written root 3 here also, because we have the constant of integration there, no? So that has to be accounted in the denominator. So these both will get cut. So yeah, you will have only 3 times root 2 tan inverse of 3x plus 1 over root 2. Why? Because these two root 3's can cancel each other when you equalize. So plus c. 5 over 6 log. Yeah, perfect. That's the entire procedure where we have, collected terms, 2-3 things coming under one roof. But that's fine. At the end of the day, this is what happens. So that's all for today's sessions. So maybe next we can meet with the next lot of problems. So as I always tell, please spread a word about the channel and see that people are there using it. Yeah, thank you.